Hello everyone. Today I will make a easy demonstration of the dissertation project which I have done. So my topic is the fair contract exchange with AWS. So in this project, I will implement a fair contract exchange system and deploy it on the Amazon Web Services, which is the AWS. I will make the presentation in four parts. The introduction and background of Fair Exchange Protocol and the global design of my system and an easy demonstration. So in the first half, in the introduction, I want to introduce what is the fair exchange and why we need it. Let's see an example. There are two users, Alice and Bob, and now Alice wants to send a contract to Bob, and she requires Bob to provide a receipt as a return. And this case is very easy in the real world. If Alice and Bob are in the same room, the Alice could give the contracts directed to the Bob and requires him to write a receipt and give back to her. So it's easy. But when this example takes place on the internet, it could be something complicated. For example, if the Alice sent the contract to the Bob by internet, but maybe the communication condition are not so well, so the contract is lost on the way. So Bob not received this contract, but Alice said, "I have already sent it." So in this case, this will cause the trust problems. And then there are a lot there are kind of protocols proposed to solve this problem, and this protocol can be called as the fair exchange protocol. So I will introduce what is the fair exchange protocol. This protocol aims to collect some evidence to prove that these things has already happened. For example, the protocol will collect the evidence of origin and the evidence of receipt. And the evidence of origin is a proof that the sender has already sent this file. And the evidence of receipt is a proof that the receiver has already provided the receipt. So the protocol will give the evidence of origin to the Bob and will give the evidence of receipt to Alice. As long as these two evidence are existed, we could ensure the fairness of the transaction. And the fair exchange protocol usually guaranteeing the fairness in two ways. The first way is to exchange the information at the same time. And the second way is to use a third trusted party to manage the exchange process. For example, the third trusted party is an authority which could be trusted both by Alice and by the Bob. They could trust this party. So this party could help them to make this exchange more fair. Um, and in this project, we use the coffee setter protocol as the fair exchange protocol of our system. So I want to make an easy introduction of this protocol. This protocol divides the whole exchange process into 5 steps. And before I introduce these steps, I want to first introduce some basic knowledge. The hash algorithm and the digital signature. The hash algorithm is a function that will hash the input into a fixed length of the output. For example, no matter I input 1 bit or 500 bits, the output will be fixed, such as 128 bits. So this is the function of the hash algorithm. And then the digital signature. This will be introduced in detail in my paper. And now I make a small introduction. The digital signature. In the digital signature, there are two keys, the private key and the public key. The sender uses his private key to encrypt this information, and the receiver could use the public key to decrypt from this information. As long as the decryption process is successful, it could be a proof that this signature is made by the sender himself. So this is plays a similar function as the signature in our daily life. It's just a digital version of the signature. So in the coffee setter protocol, there are 5 steps. In the first step, the Alice will send the identity of Alice, identity of Bob, the message, and the EOO to the TTP. The EOO is the evidence of origin, and it could be calculated like that. This is a digital signature of A, B, and the hash of the message. Then the TTP will make a verify of the information and send these informations to the Bob. So the Bob could provide the EOR, which is the evidence of receipt, to the TTP. And in the fourth step, the TTP will provide the message and the EOO to Bob. And in the final step, the TTP will give the EOR to the Alice. In this protocol, we could see the fairness could be guaranteed because both parties could get the information they want. At the final, the Alice could receive, and the Bob could get the message itself. But if Bob does not send the EOR to the TTP will also not send the message to Bob. So in this case, we could see both parties could get the information they want, or neither party can. So this is the fairness we want. And in our system, we will implement this protocol. This design graph is just similar as the protocol I have introduced. The difference is that we use the Alice email as the identity of Alice and Bob's email as the identity of Bob. So in this case, the calculation of the EOO could be here. It's a digital signature of Alice's email, Bob's email, and the hash of the file. And the EOR is in the same way. So this is the 5 steps in the protocols, and we use it in the system to ensure the fairness. Here we provide a web client for the users. Because that we have mentioned that Alice should input her email, Bob's email, upload the file. So this process could be hard to done in the command line. So we give a web client to the users to do these operations. And the web client will send all the information to the TTP, which we have mentioned here, the third trusted party. And then this is the main part of the system. And all of the data will be stored into the Amazon RDS, which is a database. And the email service, such as these middlewares, will help us to do some extension functions. For example, we can send the notification email by the email services. When Alice send a file to Bob, then the email services will send an email to Bob to notify him that, oh, you have already received a file. You can log into the system to accept this file, and so on. So this is the whole architecture of our system. And in the next step, I will make a small demonstration about how to use this application. Here is a login page, and I have already registered an account. If you have not registered, you could use this to register. And I could just log in here. For example, I'm Alice now. I will send a file to Bob. Then, yeah, we could log into our homepage. And if we want to send a file, we could click here, and we could input the email address of the receiver. Then we should input the private key here of our digital signature. I have already generated them. If you have not generated the key pairs, you could click here, generate. You click the generate key pairs to generate your own key pair. And then I just copy the digital signature here. Oh, no. Copy the private key here and choose a file. We could click send file. And then the file is already sent. We could see here, this is the file, and the receiver has not accepted this file. And now we could see, yeah, we receive a notification email in the receiver side, it says that you have received a file from the user whom Alice, and this is the notification service. And then, as a receiver, we could receive the file. Yeah, for example, we log in as Bob. And here we could see the file that we receive, and we could choose one of them to accept. For example, we choose this file, and we could copy the private key here. To copy the private key here. We could use a view file signature to see the signature first. And this is a proof that Alice has already sent a file. This is the digital signature. And then we click accept. Then this file will be downloaded from the Amazon Web Services, and we could open it. Yeah. Yeah, we can see the file is okay. So this is the receiver side. And there is also an extension function. For example, I login as Alice. For example, if I want to abort this transaction, for example, I don't want to send it anymore, and now the receiver has not received it, so I can abort this transaction. So I should input my private key here. Also copy it and click abort. The status of this transaction could be a bot. So this is an easy demonstration of the project which I have done. So I hope that this video could help you to understand my paper. And finally, thanks for listening. Bye.